Good morning, students. Today we start a new topic, that is X-ray emission spectrum. Before starting the X-ray emission spectrum, let us discuss what is characteristic radiation and what is Brahma-Stirling radiation. As we already discussed in the previous classes, the projected electron interact with the inertial electron of your target atom, and that projected electron with energy which is high enough to remove an inertial electron of the target atom, which is a tungsten. So it hits the inertial electron and removes it and create a vacancy in the inner shell. Characteristic X-rays are produced when outer shell electron fills an inner shell, as we already discussed in the previous classes. As you see in the diagram, here is an atom and you have your electron, that is the projectile electrons. It ejects the inner shell electron and the outer shell electron will come into the inner shell and take the place of the inner shell electron. During this transition, some of rays are released, that is of characteristic X-rays. Comes to the next point. Key characteristic X-ray of tungstens are only useful for the imaging, not other shells electrons emission, because only K shell electron having the sufficient binding energy that is useful for the diagnostic imaging. As you see in the diagram in the table, rest of the shells showing the less binding energy. Come to the next. Brahma-Stirling radiation. Brahma-Stirling, Brahma means anything which comes into the form of breakdown. It is produced by a projectile interacting electron interacting with the nucleus of a target atom. Let's look for the picture first. Here is your target atom, and your projectile electron will come in contact with the nuclear field, not in the contact with the nucleus. It comes into the contact of the nuclear field and it loss of all of its kinetic energy. That loss of the kinetic energy is your Brahma-Stirling X-rays. Let's look for the theory part. A projectile electron that completely avoids the orbital electrons at its pass through a target atom may come close enough to the nucleus of the atom to come under the influence of its electric field. Projectile electron kinetic energy to electromagnetic energy, which is the electrostatic force. Why the electron is not come into the contact with nucleus? Because of the electrostatic force of the repulsion. Electron is negatively charged and the nucleus is positively charged. Then there will be a force of repulsion occurs. As the projectile electron passes by the nucleus, it is slowed down and changes its energy also, leaving with reduced kinetic energy in a different direction. As we already discussed, that loss of the kinetic energy appears as an X-ray or as an Brahma-Stirling X-rays. Again, you can see the diagram. See, here you have the two projectile electron, one which comes into the very near contact and one thing which is quite far from the nucleus electric field. So that is mean the one electron will produce a low energy of Brahma-Stirling X-ray and another electron will produce the high energy Brahma-Stirling X-ray because of the influence of the electrostatic repulsion. Characteristic X-ray have a very specific energy. Key characteristic X-rays requires a tube potential of at least 70 kVp. At 70 kVp, the tube will emit the useful diagnostic beam. Brahma-Stirling X-ray that are produced can have energy level up to the set of kVp level. Brahm means anything which is produced at any projectile electron value. So comes to the next point, that is of your discrete spectrum or the X-ray emission spectrum. We will discuss in the next video.